welcome back. This is Pankaj here again. We have learned a lot of things about relation, and we have done few questions based on relation. I wanted to do a few more questions, but I thought, let me proceed with the concepts on functions, and if in case, you have any doubts, I can go back and make more videos on relations. Okay. So what I'm going to do is to now introduce you to the concept of functions, and probably do a few more questions from functions, and then shift to another chapter or another concept. Okay, so what is a function? Well, to understand a function, let's recap what's a relationship, or what's a relation. A relation is been defined as a subset of A cross B, isn't it? It's simply a subset of A cross B. I pick up ordered pairs A comma B, such that A is related to B under the relationship or whatever that's been defined. So what happens is I get ordered pairs like from A cross B, might be 1, 2, 2, 3 or something like that. Depends on what you pick up. Now when I'm actually thinking of function, let me tell you that a function is a type of a relation. A relation under certain circumstances becomes a function. Okay, so let's see that. What do I mean? Let's say, for example, I take A, and the elements of this particular set is 1, 2, and 3, and I'm going to be considering one more set B. Let me consider the set B as 2, 3, and a 4. Now obviously this has 3 elements and this has 3 elements, so A cross B is going to have 9 elements. We know that we can define 2 to the power of 9 relationships from A to B, isn't it? That's basically the number of subset that I can have from A to B. Okay, now what I'm going to do here is I'm going to be looking at a ordered pair, or basically I'm looking at a relationship. I'm looking at a relationship from A to B in such a way. I do not know what the relation could be, but let me define that for you. Okay, so in this relation, 1 will be connected to 2, 2 will be connected to 3, and 3 will be connected to 4. Now this is a relationship that I've defined. I think what the relationship is going to be picking up ordered pairs A comma B, such that the second element is 1 more than the first element. That's the relationship that's been defined in this case. We do know that this has 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 2 comma 2, 2 comma 3, and 2 comma 4, and you have 3 comma 2, 3 comma 3, and 3 comma 4. Out of all those things, I have picked up only the ordered pairs which satisfies this condition. Now this particular relationship, if you can, or this particular relation, if you actually observe, all the elements from the first set has been connected to something or the other in the second set, and it is connected to a unique value. So these are the two conditions which needs to be satisfied for a relation to become a function. Okay, so what is the first condition? The first condition is that all the elements from the first set, has an image. So you know what's an image, right? I mean, this will be called as the image, and these are called as a pre-image, and they have a unique image. Now for you to understand what this actually means, we need to look at more example and understand this particular sentence in a proper way. Okay, so first of all, we need to understand that a relationship can become a function based on these two conditions. So a function is basically a relationship itself, which is becoming a function based on the conditions mentioned here. Okay, now let me pick up another example with the same sets. So what I'm going to do here is I'm going to take two sets here. This is set A and this is set B. Again, I have 1, 2, and 3, and then I have 2, 3, and a 4. Okay, now let's say in this relationship 1 is connected to 2, 1 is also connected to 3, 2 is connected to 3, and 3 is connected to 4. Okay, so the first condition has been satisfied in this case. All the elements from the first set has an image, which is very true because 1 has an image, 2 has an image, 1 in fact has 2 images, 2 in fact has 1 image itself, and 3 in fact has 1 image. They do have all images, however the images are not unique. What do I mean? Look at this. 1 has 2 images. Now this is not supposed to be happening when I'm talking about a function, and hence this is not a function. This in fact will become now a relation only. Okay, let's look at more example. Let's say I'm taking up a connection or a correspondence from A to B. Let's say A has 1, 2, 3, 4, and this has like A, B, C, D, and E. So here let's consider 1 to be connected to D, 2 to be connected to B, and 4 to be connected to E. Well, this is not a function already because this element 3 is not connected to anything, isn't it? So the first condition for the function has not been satisfied, and hence this becomes a relation. Now let's look at another example. Okay, now if you actually look at this, in this example the first condition has been satisfied. All the elements from the first set does have some or the other image on the second set. However, if you look at 4, it is not getting connected to a unique value, rather it's getting connected to 2 different values altogether, and hence this will not be a function. This will still remain to be a relation. Let's look at one more example. Okay, in this example, if you can see, every first element has an image in the second set, and it has a unique image. Yes, it does. 2 is getting connected to a B, and 3 is getting connected to a B. That's all right. For them, they have a unique image. Here, this does not have a unique image. It has 2 different images. That's what it means when it says unique image. Okay, so this is fine. This condition is fine, and hence this is now a function and not a relation. It is a relation which has become a function because it has satisfied both the conditions. Now let's look at the last example. Here again the connection is from A to B. However, the connection seems to be fine. The first condition and the second condition has been satisfied, and hence this now becomes a function. Okay, so we have already defined the term domain, codomain, and the range, isn't it? For me, if it is a relationship, the first elements which are connected only becomes the domain, isn't it? However, for a function, the entire first set will be the domain. Only then it becomes a function. All the things has to be connected to something or the other in the second set. Only then the first set becomes a function, isn't it? Or the relationship becomes a function, and hence the entire first set becomes the domain. In the range part, the definition remains the same. The only connected values are going to be the range, and the codomain also remains the same. Okay, domain, the elements that are connected. In the case of a function, the entire first set. Range, the elements that are connected, and the codomain is going to be the entire second set. Okay, so please go back and refer to your textbooks and see what is the definition given to you for functions. Let me just check the NCERT textbook here for you. Okay, the 12th standard NCERT textbook directly starts off with types of functions. It does not give you a brief about what is a function. Well, he's right to do that because the introduction to functions has been given to you in the first year CBSE itself. Okay, so you're supposed to be knowing all these things, but that's all right. We now know it. So what do we have in the 12th CBSE textbook of NCERT textbook? What do we learn from hereafter? What we're going to learn is the different types of functions, like how we learn the different types of relationships or the different types of relations. We're now going to learn the different types of functions. Okay, the first type of function that you're going to be learning is a 1-1 function, which is otherwise called as an injective function. Alright, and then we have the onto function, otherwise called as the surjective function. And then we have 1, 1 and onto functions. A function which is both 1, 1 and onto will be called as a bijective function. Okay. Alright, wonderful. Let's see them. Okay, so we already know what is a function. A function is a relation where the two conditions are being satisfied. Now, what is a 1, 1 function or an injective function? It is a function, it is something like this. It is something like this. Let's say this is a set A, and that is a function defined from set A to set B, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and I'm defining some arbitrary function from A to B. Let's say 1 is connected to 7, 2 is connected to 6, 3 is connected to 8, 4 is connected to 10. Now if you actually look at this, the 5, okay, let me check 5 also. Okay, so the first condition has been satisfied, that all the elements are connected from the first set, and it is getting connected to a unique value. And what is the speciality of this set is that there is a 1-to-1 correspondence. You getting me? So 1 is connected to 7, no, none of them is connected to 7. So this is a 1-to-1 correspondence from the first set to the second set, and such type of function is called as a 1, 1 function. Okay, now let's look at another example here. Okay, so let's take a set A. I'm going to take a set B. 1, 2, 3, 4. And I'm going to take this as A, B, C. Okay. I'm going to write a D here and a E here. Alright. So what I'm going to do is, let's say 1 is connected to D, 2 is also connected to D, 3 is connected to B, and 4 is connected to A. Well, this is a function true because both the conditions are satisfied. However, it's not a 1, 1 function because 1 or 2 of them is connected to D itself. That should not be happening. Okay. Let's say, for example, let's say for example, 2 is not connected to D. Let's say 2 is not connected to D. Okay. So where is it getting connected to? Let's say 2 is getting connected to C. When this happens, this now turns out to become a 1, 1 function again. Yes, E is left out, that's alright. Elements being left out is fine, but this has to be a 1-to-1 correspondence. Now let's look at another example. 1, 2, 3, 4, and I have A, B, C. Okay, let's say 1 is connected to A, 2 to B, 3 to A again, 4 to. Okay, I need to take that to a C. So I'm gonna erase this out. Four is connected to C. Well, this is not a 1, 1 function. It is a function, yes, but it's not a 1, 1 function. However, I do see that all the second element has been used up, and hence this particular function will now be called as a onto function. Onto function. So basically, if the second element has been used up, the function will be called as a onto function. Now, if I can go back to the first example which I gave you here, yeah, what did I say here? I mentioned that this is a 1, 1 function, isn't it? Because there is a 1-to-1 correspondence. Also, if you take a keen look to this, the second element is all used up. There is no elements left out in the second set, and that's exactly why this function is also an onto function. So this function has a specific name or a special name given to it. This is a bijective function, which is both 1, 1 and onto. Now that's the arrow diagram way of understanding a function. The other way is to look at the order pairs and then realize what is a function and how to define a function and stuff. But the basic idea behind it is only this much. With that, we're going to stop the video for introduction to functions, And in the next video we will be looking at how to prove one and onto functions. Like in relations, the concept is easy to understand. However, while proving the questions, we approach the question in a different way altogether. Okay, so the basic concept will remain the same, but the approach of proving it will change. We will learn that in the next coming videos. Thank you for watching, and please do advise your friends to have a look at these videos and subscribe for these videos. Thank you.